Hello everyone, and thank you very much for joining me again. Today we discuss chapter 13 from Spring Start Here, which is about transactions, a very important topic out of the fundamental series, and I'm very happy you are here with me and we can discuss it. I also keep an eye on the live chat like always, so if you want to say something, don't hesitate to use the live chat. And of course, I'm looking forward for you to follow me on LinkedIn and other social media as well, and tell your friends about this channel if you like it. And with that being said, I don't want to spend too much unnecessary time of yours, and I want to already start discussing the chapter, which is a very short one, a simple one. I have only focused on the basics of the transactions, and I want to tell you this from the very beginning, because what is here in this chapter is not enough from my point of view from what you should actually know about transactions. And I'm telling you this because this is the Spring Start Here book, which means it gives you the starting point, and a very big a very big bunch of subjects are only very simplified to give you the start. It's excellent for beginners, because when you are a beginner, one of the most important things you need is the starting point, know where to start from. But I don't want you to treat this book as enough. It's not even barely enough, and that's why today I'm not only go through the chapter with you as usual, but I'm gonna also tell you some things that I consider important for you to study further. So I want you to start with this, but I also want you to continue with the topics that I'm gonna tell you, and you can find them in plenty of places. If you like books, my recommendations would be further to continue with Spring in Action from Craig Walls. There is also a Spring Boot in Practice, I think. I have to check it. And of course, if you like video tutorials, remember that there is a very detailed Spring Framework playlist on this YouTube channel of mine, which is free, where you will always find those topics, and those videos there include also the say above essentials, above foundation that you need to know about transactions. But with that being said, let's now go through today's chapter, today's topic, the transactions, chapter 13. We have already discussed about data sources last time we met, and now that you know what data sources are and how we connect from a Spring App to the database management system to operate with data in a database, now we discuss wrapping the operations in transactions to secure their consistency, because that's generally what we use transactions for. The transaction is a concept of wrapping multiple operations, usually in multiple operations, in this particular case with the DB, such that we create sort of atomicity, so they are more or less grouped as one operation. You can preview them as only one operation. And I think the simplest example I could have given is, of course, this nice drawing that shows a very simplistic representation of a money transfer. If you imagine money transfer as being as simple as taking money from an account, putting them into another account, then you already have two operations. No, it's the taking money from the first account and adding them to the second account. No, so what you want is that if you withdraw money from the from Owen's account, from John's account here, who owns $900. No, you withdraw $100 from his account. You expect that after the operation, John will have $800, and then Jane, to whom you have delivered the money will have 100 more, which will be 600. Now, what can happen is that the first operation succeeds, but the second operation fails. If something like this happens, in the majority of the cases, almost all probably, you prefer the whole thing to roll back instead of taking money from some account but not putting them in the other, no? Or the other way around. No, you can, depending on the order of the operations, adding money to an account without subtracting them from the other, no? So either way, no, if John had 1,000, Jane had 500, now you still expect at the end that the total amount of money will sum to $1,500. So in case you either end up with a smaller amount, no, or with a larger amount, then you already lost the data consistency. That is one of the main things transactions help us with. Now, I want you to keep in mind that whenever talking about transactions, we talk about 4 characteristics which are on short referred as acid. Okay, acid like acid that burns skin or acid that you take to become a little bit higher. No, not that kind of acid. Acid is actually it's an abbreviation coming from atomic, consistent, integer, and durable. Okay, so sorry, isolated and durable. Okay, atomic, consistent, isolated, and durable. And in general, the majority of the cases, developers refer to the first characteristic, which is that A coming from atomic, which is actually referring to exactly what I was telling you, what happens if one of the operations fail. No, you do not want to end up with an inconsistent inconsistent data in your database. You prefer the whole operation to roll back, so everything rolls back instead of making the changes, so it's as at the very beginning. No, atomicity means you either have all the operations executed or none of them. And that is true, that this is in most of the cases the characteristic we mostly refer to when talking about transactions. But I want you to remember that there are some details that you still need to go further and learn above the content of this chapter, and these are the propagation levels of the transactions and the isolation levels of the transactions. So once you have finished with this chapter and you understand how a transaction works behind the scenes, what it is, how you define it, like the very basics, do go a little bit more in details and also learn about the propagation and the isolation levels of the transactions. And you, if you are curious already and you want to dig into it, there are already videos on this channel in the spring playlist about both propagation and isolation. And I will answer questions because I see you have already writing me in the live chat. Thank you very much for that. So first question, do we need to put transaction on top level only? What if we put nested transactional? Not sure if I understand what on top level actually means. Propagation, because I wasn't really going into details about the propagation, but that is basically where nested comes from. So you can have a transaction, but you can have also nested transactions. How you do that in Spring with propagation levels. So you have that transaction annotation will have a propagation attribute, and then you can select the nested type if you want to have a nested transaction. So if that was the question, a little bit more advanced than this chapter, of course, but I hope I have answered you a little bit. Yes, you can have nested exceptions depending on on what you want to actually do. And again, I would redirect you better to that video where I discuss propagation levels, because there is where I discuss them more in detail, including the nested transaction type, so that you know more in detail what it is. Okay, so that is basically a transaction, grouping operations so that they become atomic, and then you can control the propagation of the transaction with Spring, and you can control the isolation. The isolation means how the transactions behave in case you have multiple transactions executing at the same time. Okay, and this is also very important. There is a default, but the default, even though it's a default because it's basically what you use in 80% of the cases or so, remember there are still situations where it's important to change the isolation level. Changing the isolation level will help you keep a better consistency, of course, on the compromise of performance. Now it's a very tricky. The isolation levels can be very tricky. We have 4 isolation levels. They are read committed, read uncommitted, repeatable read, and serializable, and depending on what you choose, you will have either less consistency but better performance, or a lot of consistency with very slow performance. This is detail that an experienced developer needs to know, and that's why again I invite you check out the other video where we discuss that, the isolation levels in detail. But again, here in this chapter 13 we only talk about what a transaction is, and then how it works with Spring, and that's the very basic important you need to know before trying to understand more about it. Take a look at this diagram. This tells you mainly how the transactions work behind the scenes in a Spring application. First of all, imagine we have a linear design, that kind of controller service repository you are probably already accustomed with, and that's because it's easier to think about it this way. Now, probably the majority of you have already seen or even worked, and theoretically you have seen this at least in the previous chapters of this book. You have the controller exposing an endpoint. Here you have an example of an endpoint called transfer money. The post mapping annotation, which we have seen a few chapters ago when we discussed REST endpoints. And then this controller delegates to a service layer. And remember, the service objects, they are their responsibility is to implement the business logic. Here is where the business logic happens. In our case, is referring back to the simplistic representation of our transaction, is withdrawing money from the source account, depositing the money into a destination account. No, this is the logic of our so-called transfer money operation. And then what you will see is that this method is annotated with transactional. Now, later on in this chapter, you will see that transactional can be used also on the class level to refer to all the methods of a service, and it's very often that you will see transactional annotation at the class level as well. But for the moment, let's see it here and refer to the method. So assume we have this method annotated with @transactional. What actually happens at this moment is that Spring will know to enable an aspect which will automatically come before, actually it will be an around aspect. Please, in case this is something that you don't remember or you need a refresher, please go back to chapter 6. using aspects with Spring AOP. This is a very important chapter to understand a lot of the capabilities Spring provides, including the transactionability and the security for method security, that usage of pre-authorize, post-authorize, which you find, for example, in another book I wrote called Spring Start Here. So when you do that, when you annotate the method with transactional, Spring automatically enables an aspect which will come in between controller and service, the controller and the service. So it will actually be around, is that the way we call that join point was around, we say it wraps the execution of the transfer money method which was annotated with transactional and applies logic to it, enhances it, augments it with logic. This is basically what it does, and here you can see a very minimalistic representation of what it actually does. Now, instead of having the controller directly calling the transfer money, which does each operation individual, we will have the controller calling this aspect which starts a transaction, calls then the intercepted method, commits the transaction if no exception, if no runtime exception was thrown by this method, or rollbacks the transaction automatically for any runtime exception that has been thrown from the transfer money method of the service. So all this code in this aspect is basically boilerplate code that Spring removes it from your site. You do not see it, but it exists somewhere. And once you have added your transactional annotation, you have automatically enabled this capability, which Spring automatically does for you without having you to worry too much about it. So, do you have a suggestion about a book about compiling and JVM and memory? Because without that, it's hard to understand some subjects deeply, like generosity and IOP and threads. Let's take this discussion later. Maybe ping me on LinkedIn and let's discuss about it, because it's a different topic and I don't want to disturb the current stream. Okay, thank you very much, or leave me a comment in the comment section. Cool. So going back to this, I hope this is much clearer now. No, if you don't have this annotation, then the controller will call directly a service. Once you have this annotation here, automatically this aspect appears somewhere in this aspect, which will be called the transaction is started and either committed or rolled back, depending on the method's execution. And this is why it's very important to remember that Spring, by default, if you don't configure anything particularly, will automatically roll back any transaction whenever a runtime exception is thrown out of the intercepted method. But one of the things that I observe with beginners is that sometimes they don't understand this concept very well, and what they do is they add a try catch here in the transfer money methods in the service, and they catch the exception and they log something, or they somehow swallow that exception. And problematic is if you do that, if you treat the exception inside the money transfer method here, it will not be thrown out, which means that this try catch will not know about it, and then the rollback will not happen. So a very important thing to understand and a very important thing to observe from this diagram is that it needs the exception thrown here needs to get out of the method to be propagated to where the method has been called in the aspect to be able to be seen by the transaction aspect, so that it rolls back the transaction. Do not add a try catch inside here to swallow exceptions, because if you do that, then the transactional will not work appropriately anymore. Okay. And by default, again to mention it, only runtime exceptions will be rolled back. If you have checked exceptions, those that you have to, for which if you don't treat them explicitly, you will have to add a throws clause here, throws exception, for example, no? Throws IO exception, throws, I don't know what, checked exception, whatever checked exception, can be even a custom one. Those exceptions which are thrown on purposely, they are not rolled back, at least not out of the box. You can configure transactional both to roll back for checked exceptions and not to roll back for runtime exceptions, but out of the box this will not happen. Out of the box the rollback will only happen for the propagated runtime exceptions, and there will be no rollback for the propagated checked exceptions. Okay, this is another thing that is important to keep in mind. Okay, so this is what I was explaining. No, this is what I was explaining earlier. If you add a try catch and swallow this exception here, it will not get propagated anymore. So guess what will happen? No, follow it with me step by step. Service transfer money will be called, a transaction will be started, the intercepted method is called, point 1 is executed, point 2 will throw a runtime exception, the catch will catch the runtime exception but it will not propagate the exception, and then because there is no propagated exception, this try catch will not see that exception anymore because it was already treated here, and will commit the transaction, and you will end up with an inconsistency. Okay, so this is why this is very important. Treating exception for transactions is one of the core skills, core knowledge that you need to have when implementing transactions. So what we should do then in case of checked exceptions, roll back manually. This is a very good question. Depends. It depends. No. So checked exceptions have been taught as being exceptions that you explicitly propagate, and you by this you do not want because they represent potentially a part of your business flow. They are for you to manually treat them. But if you really want Spring to roll back an exception for you, then the transactional method has an attribute called a rollback for. So you add the rollback for, and then you mention all the exceptions you want Spring to roll back, even, and you particularly use that for exceptions which are checked. Okay, so this is the way you can instruct Spring to even roll back a transaction for even a checked exception. This is how you do it. And there is also the opposite. There is an attribute called no rollback for, and that is if you want to alter the Spring behavior in the opposite way. You want to not roll back, to commit for a runtime exception on purpose. I don't know why would you do that. I don't think there is any place where that would be a best practice, but Spring is flexible enough and it allows you to no rollback in case that's what you need for I don't know what reason. Okay, so you can basically do that. So can you please take us a one session on AOP? There is already one session on AOP. Chapter 6 here is one of them. So what you can do, you can go to chapter 6 on this same playlist and review the AOP. And there are more discussions about AOP also in the Spring playlist. So just go back or use the videos in the Spring Fundamentals playlist, okay? And you will find the discussion about AOP as well there. So we are now discussing chapter 13 now already. I do assume that you have already seen all the previous chapters, or you at least have the knowledge already from those chapters, no? And Again, of course, the book answers you the question, what about checked exceptions in transactions? No, because we have discussed about checked exceptions, and it tells you that whenever you add the throws, no, the transactional annotation has attributes. I have already told you which are those attributes. No, they are the rollback for and no rollback for, which you can use. We will see them later. Okay, and then using transactions, we implement this example, and I remind you that all the projects used in my books and in many books in general, you find the projects free to download on the book's main page. So if you go on manning.com website, you search the book, somewhere on the left bar you have a way in which you can download these projects and run them. So you can basically try out what we discuss here. This is, for example, the chapter, the project named SQ chapter 13 example 1. And then, of course, you first start with the dependencies in your POM XML. Here I present the idea of using a Spring Boot Starter Data JDBC, which enables me to use Spring JDBC, which we have discussed in chapter 12. And then I demonstrate here how you define the repository for the operations you need. I'm gonna quickly step over this because you already know them from chapter 12. And I'm gonna focus directly on the service now, where you can see the new stuff here appeared is the transactional annotation. So only by adding this, I now make sure that the call of the transfer money method is wrapped in the transaction. So then if one of the operations succeeds but the other one will fail, or any runtime exception, if any runtime exception is thrown, then automatically Spring will take care and will roll back the change. Now you have also a sequence diagram presenting what happens. Now you see here it takes find account by ID, then it subtracts and adds the amount, and then it changes the amount. So it makes a select query and then another select query, and then it calculates the amounts to be updated, and it updates both of the accounts. If any of these fails, everything is rolled back. And then I know what you will ask me. You will ask me, hey, but if I had only select queries in my use case, does it make sense to have transactions? And then the answer is it depends again. Why it depends? Because adding a transaction adds some more overwhelm over the operation. So sometimes running a select query without a transaction might make sense, but it depends on whether you want to be able to isolate it or not from other operations. Sometimes we do use transactions with select queries as well, even if we only have select queries and no updates, not because we want to be able to roll back, because having only selects, you don't have what to roll back, but because you want to be able to use those isolation levels I was telling you about to isolate the queries, to make them execute in certain situations one after the other, for example. And that's why I'm going to invite you again after you feel comfortable with understanding really what a transaction is, to go to the propagation and isolation levels and study the transactions more in detail, because both propagation levels and isolation levels, they are very good skill for any Spring developer. It will tell you why, for example, in some cases, even if you only have select queries, you still want to have transactions, when to have transactions, and when it's better not to have transactions, and how can you, for example, execute only one query from an entire transaction without transaction. No, for example, can I here make the account, this find by account ID, execute without a transaction? The answer is yes, I can. How do I do that? With propagation levels. The propagation levels would allow you to do something like that. So see, this propagation and isolation level, they do offer you a lot of flexibility on what you do to how you want those transactions to behave. Question: if when putting rollback for IO exception, Spring will rollback also for runtime exception? Yes. So if you use the rollback for, just the rollback for, and then you enumerate whatever checked exceptions, that means Spring will rollback for IO exception and any other enumerated checked exception, but will still roll back for all the runtime exceptions. If you have a null pointer exception or an index out of bounds exception or even a generic runtime exception, all of this will be automatically treated by Spring if you don't configure anything explicitly. So or setting the rollback for attributes is for adding other exceptions which are checked that you want to be also rollbacked above all the runtime exceptions. So you do not lose capability, no? Okay, and we have already discussed this, no? And then what we discussed now, that the transactional annotation can also be applied directly to the class now, and you can see it here. I moved the transactional annotation at the class level instead of method level, and this is very comfortable because sometimes, first of all, I do recommend that anyway, putting the transactional at the class level. It's for services particularly where in majority of the cases you do want to have transactions, you help developers avoid forgetting to add the annotation, first of all. Secondly, you eliminate the need of putting it on each and every method, eliminating a part of the boilerplate code, making the code base shorter and easier to read. And then remember, always what it is at the class level will be overwritten if you add a transactional annotation at the method level. So for example, if you want to add a transactional here, but then you want this method, just this method, to behave differently, you can still add the transactional over that method and configure what you want here to happen differently than what you have defined at the class level. So the method level transactional overrides the class level, and that offers you the flexibility to, for example, set here transactional, I saw that in many cases, no, transactional read only, and then override the read only for methods that write in the database, or transactional propagation, I don't know, requires new, and then override it for what you need. So depending on the application, it offers you this flexibility, no? And then this continues, of course, the example showing us that this works according to what we expected. I'm gonna skip over it because we have already discussed this, and we have discussed all the behavior now, including what happens if an exception is thrown and the rollback happens. And you see here it demonstrates, basically I demonstrate in this chapter that this really happens, no? So basically that's it in terms of what I consider to be the very foundation, which is understanding very well what a transaction is and how exceptions work. And now you have to go one step further, and that is discuss the isolation and the propagation levels. If you know that with transactions, you should be able to understand and write any capability where transactionability is needed. And I will point one more thing before ending this today's live. I'm gonna go back to the aspect here, and I'm gonna refer now to what happens, because my whole examples were the controller, which was a class, calls service, which is a different class, which is the, let's say, correct way of working. But I have seen sometimes developers trying to call a transactional annotated method in the same class from a method of the same class. So if you would have two methods inside the service and one calls another directly, remember from chapter 6 that annotations will not be interpreted, because in that case there will be no way in which the aspect can be woven to intercept that method. So never rely on direct calls in the same class. And I wanted to enforce that one more time. I think we have discussed it in chapter 6 as well. But again, I wanted to enforce this one more time because I've seen developers trying to, for example, use the propagation level requires new, and then they didn't understand why a new transaction was not created, because they were actually trying to call it in the same class, and then the aspect cannot weave over that, and that means there was actually no capability, no transactional capability. No, this is the same thing here. So make sure that you understand whenever you rely on aspects with Spring and you want to have a method intercepted based on an annotation, regardless it's transactional, pre-authorized, post-authorized, any other annotation that you add on the method level with the purpose of intercepting that method, it always needs to be from one object to another to go through the proxy. Okay, otherwise this will not work. So let's see, we have more questions. Okay, this is more Spring Security related one, and it's in Romanian, but I will try to be very quick. So I do recommend you use Keycloak, and I do recommend you avoid as much as possible customizing security implementations. Spring already offers you almost everything you need, and you can customize only what really makes sense. By customizing, usually, and that applies even to things like transactions, by customizing, by making your custom implementation, usually you only add more possible risk to your apps. Risk meaning you introduce bugs because it's then an implementation that only you are using. You might have different vulnerabilities you are not aware of. Imagine that Spring, when it comes with a capability, it's like transactionability or Spring Security or anything. That capability is used by hundreds of thousands of applications around the world. So it's rather likely that someone would find a bug rather than if you try to re-implement it. So that's why I'm always advising people to developers to use what exists and try to use the standards and everything and customize as less as possible. Is it possible to put a class level transactional and then exclude, to say, one method from transactional? Yes, it is possible. Yeah, very good question actually. You can do that still by using propagation levels. It was not here, but in case you'd like to do that, so for example, let's say you want to exclude the transfer money, you would add here add transactional and then use the propagation level called not required. So in that case, we'll automatically exclude. It's basically like you are saying this method doesn't need a transaction. Okay, that is the way in which you can basically override anything. In reality, you can customize absolutely anything, including making a method act without a transaction if you want. And again, for this you use those propagations level now that I was telling you you need to learn as well. So next point you want to become strong with propagation levels and isolation levels. With that being said, friends, again, thank you very much for being here, and see you next time where we discuss chapter 14 about Spring Data. So I will take you now to an abstract layer, and I will tell you how to work more efficiently with your persistent implementation, but also how to choose from multiple Spring Data implementations, because there is no one Spring Data implementation, and Spring Data doesn't always mean JPA and Hibernate, and that is what I want to teach you next time. But until then, thank you very much for being here with me, and have an excellent time for study further. Cheers, everyone.